Hello, Dr. Julian Onions.
Hello,
Nice to
how
have
are
you
you?
back. Yep, doing good. How are you?
Yeah, good, thanks.
Yep. Sorry for keeping you waiting, Dr.
No,
Julian Onions, because we had a bit of technical issues that we had to correct.
no
So
problem.
sorry about that. So yeah. So Dr. Julian, are you ready for today's question and answer session?
Absolutely.
All right then. So let me share the screen so that y'all can see the questions that we have today. Okay, so is my screen visible on your side?
Yep, I can see that.
Yep. All right. Perfect. So for today's theme, we have the significance of learning astronomy and coding for a brighter future. So we have divided this question and answer session into two segments. So the first one will be based on astronomy, and the second segment will be based on coding. So we got five to six questions for astronomy and around 5 to 6 questions for coding as well. So shall we begin, Dr. Julian?
Yes, ready when you are.
All right. Okay. Thank you. So first we have astronomy. So the first question is, do you believe that astronomy should be taught in schools? Because mostly if you see in schools in Sri Lanka, so astronomy is not a subject which is available for most of the kids to choose, even though they are interested in learning it. So as an astrophysicist, what do you believe? Do you think that it's a good idea to teach astronomy in schools?
I think it's, well, yes and no. So I think it's a good idea, but I mean, we don't teach astronomy as a subject in this country either for primary or secondary school. So up to about the age of 16, it is taught a little bit in some of the physics classes, but
Okay.
not as a subject on its own. There is what we have here is a GCSE, which is what you take at age 16. As there is a GCSE astronomy, but that's taught as a extra thing that some schools can opt into, but it's not a general thing. So I think it's probably a little specialized to be taught as a sort of formally examined subject, but I think it is very useful to be taught some astronomy as part of your education, just so that you understand the world and the universe we live in.
All right. Okay. Thank you for that, Dr. Julian. So I hope the students here would have understood the answer to that question. So let's move on to the next question that we have today, the second question. So that's going to be, what advice can you give the students who are interested in learning about astronomy, but are unable to learn it from school?
Oh, that's a really good question. So if you want to learn about astronomy, there are some really, really good YouTube videos on the subject. You have to look around a bit to get the good ones. There's also some very useful courses that you can self-study. So there's I think they're still free. There's something called Future Learn in the UK that's run by a group of universities out of the UK and other places, where they have some courses. I know there's one called the night sky, or exploring the night sky in and around Orion, or something like that. And that's a very good course for introduction. Leads you through understanding the stars and how they live and things like that. It's very approachable. I think all your students could probably tackle that one, for instance. And there's a few other courses. There's another one I know on the same platform called Future Learn about the moons of the solar system. And there is another one, which I can't remember, but they are mostly free courses. You can pay for them if you want a certificate, but you can just study them otherwise. And they've also released the material for free anyway. So that's a really good introduction to it. You get to learn a little bit about astronomy, and you have to answer a few questions along the way just to check that you've understood it.
That's great.
But it's not particularly taxing. It doesn't need a lot of mathematical knowledge for that one.
All right. So, Dr. Julian, so is there any entry-level criteria that in order for you to do these courses online?
No, none at all. You just turn up, and some of them run at certain periods, so you have to sort of wait for the next version of it to start. But some of them are, they just present you with the material and say, work through it at your own pace. And it's usually about a 3 to 4 week course that you just have to work through.
All right.
So you
And
can
just
either
one
do
more
it
question.
individually
Yeah.
or as a team or something like that.
All right. That's really great. And one more question that I want to add to this is that do you believe that it's actually possible for someone who's interested in astronomy to learn it, like, be a self-taught rather than depending on someone to teach them the subject? Do you believe that it's possible?
It's certainly possible. I've done similar things with other courses, not in astronomy because I've been taught that, but I have tried other courses on different things like, I don't know, anatomy and things like that I don't know much about. So if you're really interested in the course, you can pick it up, and they are, as long as you pick the right course. There are some courses out there that are a bit advanced that you would need pre-knowledge for, but if you pick some of these more entry-level courses, then they will bring you up, and I'm sure all your students were quite capable of that.
All right. Thank you, Dr. Julian. And just one more request that I want to make, Dr. Julian. So if you don't mind, could you recommend few courses that will be suitable for kids around the age of 9 to 13 so that we can share it with our students over here so that they can.
Yeah, I'll send you some after this
sure.
After this conference. And
thank you very much. Thank you very much, Dr. Julian. So let's see what we have for the third question. All right, so this is the third question. So what are the steps a student can take to prepare him or herself to pursue a career in astronomy in future?
Right, the two things that you really need if you want to go for a career in astronomy, the two things you need to build on are physics and mathematics. So those are the two key things that any institution that you go to will require. So you need qualifications in both of those. So it depends a little on exactly what area you're interested in. Some areas of astronomy need a lot more maths than others, but they all need some level of maths. So if you're not good with maths, then you're going to struggle. I think that's the downside.
All right. So for a student who has graduated from high school, so what's the next step that he can take, given the fact that he has selected physics and mathematics for his A levels?
Yeah. So if you've got physics and maths A levels, then you're in a very good place. If you've done further maths A level, that's even better. But then you would go for a degree in physics. That's nearly always the next step. Sometimes they do physics with astronomy. Nottingham University, for instance, do that, but that's not necessary. All you need really is a degree in physics to get to the next step. After you've got your degree in physics, then if you're going for a career, the next thing you need is a PhD, which is a doctorate in astronomy. And so a degree is usually 3 or 4 years, and a PhD is usually 3 or 4 years as well. So you can work out that you're going to be 6 to 8 years after your 18th birthday before you're ready.
All right. Okay. So that seems like a really long procedure, but yeah. So I think it's worthwhile, right? If you're interested in pursuing it. So I don't think that will be a hindrance.
Yeah, if you're interested in the subject, it's great. But yeah, if you're not interested in it, it can be hard work. So
exactly. All right.
To be interested.
Thank you for that, Dr. Julian. So let's move on to the fourth question that we have today. Okay, so is astronomy a good career? If so, is it challenging or unchallenging?
It's certainly challenging because just the nature of the subject, there is quite a lot of maths and quite a lot of physics to understand, and it depends which particular area you go into it. It is a very good career though, even if you don't end up becoming a professional astronomer, and it is quite hard to become a professional astronomer because there just aren't that many jobs in it. But for instance, the people who do PhDs, so they become doctors in astronomy at Nottingham, I would say less than half go on to be a career in astronomy, but they get very good jobs as a result of studying that. They often go into finance or media or all sorts of jobs, and they get paid a lot better than they do as astronomer, I have to say. So it's a very good foundation for, even if you've decided at the end of it that it's probably not for you, you are in a very good position to get a very good job afterwards.
All right. Just one more thing that I want to add, Dr. Julian, is that I have heard most of the kids in our astronomy camp. So what they tell me is that they would like to work for a space agency like NASA or ESA or SpaceX, example. So does it necessarily mean that, if you have a career in astronomy, that you have to work for a space agency? So apart from space agency, does that mean that you don't have anything else that you can do? So does that mean you have to get into a space agency?
No, not at all. No, in fact, very few astronomers work for either NASA or ESA or any of the others. Most astronomers work for universities. So like me, I work at a university. We work, it's a very collaborative thing when you get into working. So you tend to work with other people. So I've worked with people at NASA, and the way it works is often you want to research a particular area of astronomy, and you look for some money for that. So you get a grant, and that might be from, I don't know, the UK government, it might be from ESA, it might be from NASA. And if you get one of these grants, you're effectively working for NASA at that point. Even though you, like me, you live and work in Nottingham University, you are then sort of paid by NASA effectively. So it's not a case that you have to end up at NASA, although that is certainly a possibility. But there's lots of other places. You could work from Sri Lanka, you could work from Australia and still be part of the NASA family or the ESA family. You could also get a job at ESA and NASA. Those are also possibilities, and they do. One of the students from Nottingham did get a job and now works with ESA, but they don't work on rockets or anything like that. They work on studying the universe.
So it's basically research, right? So
research, and once you're into research, you can sort of go anywhere you like, including NASA. If you get interested in something that NASA is working on, then you might well end up working with NASA or for NASA.
All right, that's good. Thank you, Dr. Julian. So let's move on to the fifth question that we have today. All right, so the fifth question is, why is programming an essential part in pursuing a career in astronomy?
Right, that's a really good question, because a lot of people who aren't in astronomy think astronomers spend all their time looking through telescopes, and that is less and less the case these days. Nearly all our PhD students who are working for a career, they spend their time programming, not particularly complicated programming, but it's about taking the data that comes from these telescopes and analyzing it. And because there are so many thousands and thousands of images or millions of images from telescopes now, you really have to do it by computer. You can't look at each image. So you need to be able to program to process the number of images. So nearly everybody spends all day at a computer, either programming or looking at graphs or writing code or debugging code. So it's a very crucial part of astronomy and quite a lot of other physics today.
So basically in the present time, so it's not only you've got to be good at maths or physics, it should be maths, physics, and computing.
Certainly computing really does help. You don't have to be sort of a brilliant programmer. You have to know enough to be able to do what you need to do. So it might just be reading in some data and plotting a graph of it, but doing it hundreds of times. So if you've got a program that does that effectively, then you can race through these images and find out what you're looking for.
I'm a bit curious, Dr. Julian. Usually, so stuff like you said, right? So you plot graphs and stuff with research that you have been doing. So are these all automated, or do you do that manually, like programming it yourself, or do you have applications and softwares that will do it for you?
We have some applications that will do absolutely everything for you if you happen to be working in the right area, because it's a very big area and people have written these things before. But most cases, you take a bit of this and a bit of that, so you and you glue it together. So there are lots of libraries for plotting graphs, and there's lots of libraries for reading data in. So you take one of those and you can read in your data, and then you have to pass it over to this other thing that will plot the graph for you. And it's the bit in between that you have to do the programming to sort of match up one to the other. Right. So it's not particularly complicated as long as you get the right things. You don't have to plot all the graphs by hand. There's plenty of software to help you do that, but not necessarily in the way you want it. So you have to go and fiddle around until you get the graph exactly how you want. Because right, so ultimately these graphs usually end up in scientific papers that are published. So you want them to look very nice.
All right. So it's basically you've got to have some sound knowledge on operating those applications.
Absolutely, yes.
All right. Okay, perfect. Thank you, Dr. Julian. So let's move on to the next question. So I think this is the last question on the astronomy. So this is importance of astronomy in modern education.
Yeah, well, it's a key part of education, I think, understanding some astronomy. So it's certainly a topic that is worth exploring. It's not for everybody, I have to say. Probably is for all the students you have because they're very interested in it, but not everybody is interested in it. But we do quite a lot of outreach. So we have groups who, used to come into the university before COVID at least, and we would show them the stars, we would show them telescopes, we'd show them how we work. And it's all very interesting for them, and I hope it inspires some of them. But it's not going to inspire everybody. Everybody's different.
All right. Okay. So that actually makes sense as well. So yeah. And just one more thing that I want to ask you, Dr. Julian, is that you told us that there are resources, there are free courses online that students can pursue, and they are of different of different levels. Some are basic, some are advanced. And just one more question that I want to ask is that most of the kids here in Sri Lanka are unable to afford telescopes and stuff to observe the night sky, or to observe basically anything. So is there any application out there on the internet which is free of charge for a kid to use, where they can explore the solar system and basically the entire Milky Way galaxies, and anything that helps them with the observation of the cosmos?
I'm trying to think. There are some applications
because Dr. Julian, sorry for interrupting, because I have actually come up with, I have actually come across few applications on the internet, but they seem to be really complicated to, operate. Because even for me, like I had to go through few tutorials to, get to know how to, use that application, because it's not that simple. So yeah. Is there anything which is much simpler to use out there that
I can't think of anything offhand that lets you view things directly. I know one of the courses that I'm probably going to recommend does allow you to use a robotic telescope as part of it to take images, but operating a big telescope is quite complicated, so it does take quite a bit of training, even if you're not manually, if you're not physically using it. Okay. So those are a little difficult. If you just want to look at the night sky through a telescope, we, at least in the UK, we usually recommend you go to an astronomy society, an amateur group, because they have better telescopes often than we have, say at Nottingham University, because we do our main research using telescopes in other countries. So if you just want to look at planets and galaxies and things like that, we usually recommend you go to an amateur astronomy group and just borrow their telescopes, or often they have star parties where they will have telescopes set up that you can look through at different objects. Because it does take a little bit of work to set these things up and get the best out of them.
All right. Okay. Thank you for that, Dr. Julian. So I think this is the last question under astronomy. So next we'll move on to coding. So yeah, so we have coding. So the first question under coding is that how important is it to know coding in this digitalized era?
I think it's going to be more and more important as the years go on. I say it used to be the case that astronomers would take pictures and they would look at the pictures and try and work out what was going on. And almost nobody does that now. They all use computer programs. And this is the case in nearly all disciplines in physics, that you have to know some coding to be able to do that. You don't have to be a super duper programmer to get ahead in this, but the more coding that you understand, the easier it is to just get stuff that works for you. And that's true really across more and more disciplines. So I said a lot of our astronomy graduates, they go on to go into finance or something like that. And again, they're not adding up numbers, they're making models of financial systems, and that is again programming. So they take that stuff they've learned for astronomy and they apply it to financial models or production models or anything like that. So it's getting more and more important that you do know some level of coding to move forwards.
All right. So just one more thing, Dr. Julian. So do you believe that, at some point, although it's taking place right now, but do you believe that at some point in time, like anyone who is into any field, doesn't have to be astronomy, could be accounting, management, health sector, or any kind of job that they're doing, they should know coding. The coding will be the most important thing to be included in their resume, because without coding, do you believe that there won't be any job for that person?
I don't think it stops you from any job, but it would help you in a way. It depends a lot on the job. If you're going to be a computer programmer, then you definitely need to know coding. If you're going to be a doctor, you don't necessarily need coding, but if you do know a little bit, it can really help improve your day-to-day life. And if you're somewhere in between, like somewhat like a financial analyzer or something like that, then the more you know, the better you're going to be at it. Even though it may not be your core job, it's going to really help you.
Okay.
So I just think it's going to be the more you know about it, the better for you.
All right. Okay. Thank you for that, Dr. Julian. So, because today we have both students who are from our coding camp as well as from our astronomy camp. So that's the reason why we based this topic for both astronomy and coding at the same time.
Mm-hmm.
All right. So let's move on to the second question that we have. So the second question is, can anyone become a programmer, or is it only for those who are mathematical or analytical thinkers?
Oh, I think anybody can become a programmer. It depends to what level you want to take it. If you want to be a professional programmer who writes software for a living, then you need some level of mathematics. You don't need to be hugely mathematical. You need to really understand what you're doing and how to process data, and the right way to do it and the most efficient way to do it. It's a sort of art on its own, really. And some people are very good mathematicians and some people are very good programmers, and some people are very good at both, but you don't need to be a good programmer. You don't necessarily need to be a very good mathematician. So it really depends what you want to do. If you're doing, I don't know, textual analysis or stuff like that, you don't need particularly strong mathematical skills. Maths always helps. I think it's a bit like, programming always helps you with almost any job, and maths does help you, but you don't need to be, way up there in the mathematical ability to be a good coder. You really need to understand how computers work and how they function to be able to take advantage of what they can bring to you.
All right. So Dr. Julian, so would you recommend programming to someone who is, not that good at, problem solving, someone who is not really good at, making decisions in real time? So would you recommend programming for a person like that?
Yeah, I think you have to. Programming is a bit like solving puzzles in some cases. You know what you want to do. You're not quite sure how to do it, so you have to think around the subject and think, how would I do this? What do I need to take, and what do I need to produce, and how can I bring those two things together? And sometimes a light comes on in your head, and you think, oh, I know how to do this. I just need to do this and this, and it all happens. And sometimes it's a lot more complicated than that. But in most cases, you can find somebody who's done something similar to what you want to do, and you can just borrow that and extend it. So you don't have to write everything right from the very beginning. You can use what other people have done previously and base your work on that.
All right. Okay. So that was really informative. Thank you, Dr. Julian. So let's move on to the third question. How can a student become a programmer? What are the steps that you would recommend?
So you need to become familiar in some computer language. I would recommend, if you're going to start, to pick what we call an interpreted language. So this is one where you can just type things in. So in astronomy and a lot of physics, a lot of our work is using the Python programming language. So that's quite an easy one to learn and pick up, because you can actually just type things into the screen and say, 5 times 7, and it'll print out the answer, and you can work from that upwards. So you can get some of the way just by playing with it. There are certainly for Python, I know there are online courses all over the place.
Dr. Julian, does it have to be a language which is having less syntax, like Python?
Not particularly. You go with whatever language you like, really. And once you've learned one, it's not that difficult to learn another one. Once you've got the concepts into your head about how everything works, it's fairly easy to go to another programming language. I use about 4 to 5 different programming languages almost day to day. So I can easily move between those. And I can write programs in probably another 10 or 20 computer languages. So it's not that difficult once you've learned one and you know how they work. It's just learning the sort of little differences between that and the other languages. So if you want to go, whatever language you start with, it's not, once you're sort of okay in that language, it's not that difficult to go to a different one.
All right. Thank you, Dr. Julian. So let's move on to the fourth question that we have. So the first question is specializing in one language better than learning many? Because I have seen most of the new programmers, right? The self-taught programmers, they try to learn every single language that's out there or that's trending. So lastly, they end up losing interest in programming and they just quit. So what do you think is the best way of learning a language?
I think you need to spend enough time with the language to get very familiar with it, so you can write whatever most programs you want to. And then usually you find it depends what you're going to do with that, what you're going to do next. And you may find there's a better language that gives you what you need for that particular application. So if you want to analyze data, for instance, we use Python a lot, but it's not super fast as a language. So if you need to process a lot of data regularly, you may switch to a compiled language like C or C++ or something like that. And in other cases, you may find there is a set of libraries and things written already for this particular language. So another one is R, for instance, very good for data analysis. So you may find that, I don't know, if you're working with a particular telescope, for instance, to take it back to astronomy, they've already produced a lot of code in this R language that takes their data and presents it to you. So in that case, it would be good to switch, if you started with Python, it would be good to switch to R at that point, because it's just going to be a lot easier. And similarly in financial world, but they often have their favorite language, which they have a lot of invested history in. So again, you switch to that. If you're going to do web programming, then something like PHP or other languages like that make displaying things on web interfaces much easier. So yeah, it's I think getting a good grounding in one language and sticking with that to begin with is a very good start, because whatever you learn in that, you can take to your next language.
Okay. Thank you, Dr. Julian. So just one more thing that I would like to know is that, so in our coding camp, so we teach kids Python, Lua, Java, and Scratch. So what do you think about these programming languages as a programmer yourself? So what do you think about it?
They're all very good. I don't know Scratch very well. I have seen, I think my son used it a bit. So Python, I say we use an awful lot in astronomy, and they use it a lot throughout physics because it's it's free and it's very easy to use, and there is a lot of stuff to use that. So there's a whole set of libraries to deal with astronomy. So if you want to, I don't know, analyze a galaxy or something, there is already a library written to analyze galaxies. So you just have to call that. Lua, we don't use quite so much. I have used that in programming. It's very good as an embedded language. So if you've got a program that you need to change in some ways, having Lua plugged into that is very good. I forgot what your other language was apart from Scratch, but they're all very good choices.
All right.
So,
okay.
If you learn something in those languages, that it's very easy to take that to different programming language. Oh, Java, yes, Java's very good for web development and other things.
All right. Thank you for that, Dr. Julian. So this is just another question which is not related to this. So I just remembered this. So earlier under astronomy, we were talking about, how to become, an astrophysicist or an astronomer, and then you get into, if you're lucky enough, you get into a space agency, and if you don't, you can work for a university, and there are so many career options for that. So when it comes to coding and stuff, so we actually discussed about the process of becoming a programmer. So once we become a programmer, what are the career choices that we have? Like how can we get into, the top-notch companies like Apple, Google, basically the entire Silicon Valley? How can that be done?
Yeah, that's a good question. So that's easier than becoming an astronomer, I have to say, just because there are so many companies, very good programmers. So if you're a programmer of any ability, I'm sure you would find a job because there are just so many these days. If you want to get into Google, you have to be pretty good. You have to be a good programmer, or similarly Apple, or be very good in a particularly specialized application. So if you're very good at, I don't know, taking GPS signals and working out maps and things like that, then there might well be an opening. But in general, to get into one of those top companies. You need to just be a very good programmer, and you probably need a degree in computer programming or computer science, but you may not need a doctorate or something like that. They look more to experience. So they don't usually, I don't know, they may take on graduates from universities, but more often I think they take people who have some experience. So often you have to start by working in some other company and getting your experience so that you learn how to program and you learn how it all works together as a group. And then you would go on from that and perhaps apply to one of these companies and say, look, I've been doing this for 3 years and I'm very good at it now. So I might have skills that you want.
All right. Okay. So basically, so when it comes to programming or coding, it's not just about, gathering knowledge, right? So do you believe that, students should start, building applications, start coding projects so that, before they get into an actual job or an internship, they are, skilled, or they have the enough experience working and, creating and developing projects. So do you think that it's an important thing when it comes to programming?
Yeah, so certainly you would need to be reasonably good at programming to get started. But then the next step, really, whichever company you work for, you would not work normally as a single individual just coding on their own. You would work as a part of a team. So it's quite useful at that point to get to understand how you work as a team. So you would program on your own, but you would program with groups of other people. So you might be working on this part of the application and somebody else is working on that application. And obviously they have to meet and work together. So there are tools that would help you do things like that, source code control and things like that, so places like GitHub that let you store your programs and work as a team. Those are quite important to get to know, because certainly if you work for a professional software company, they don't just want you to program, they want you to also test your code so that you know it works and you can prove it works, and they want it controlled under source code control so that if you make a change, you can, and it all goes wrong, you can undo that change and get back to a system that works. Nobody wants to wipe out Facebook across the planet, but because they made a silly mistake, they want it to be perfect every time it comes out.
All right. Okay.
Testing programs and working as a team are also key and important things.
Thank you, Dr. Julian. So we got the last question for today. So that's going to be, how does coding and astronomy relate to each other?
Well, as I said, it's a really strong connection, certainly these days. I don't think anybody, none of our PhD students who are working on their doctorate can manage without doing some coding, and in often cases, a lot of coding. So it's a really important skill. And not all of them have learnt programming particularly. Sometimes they have to learn it quite quickly once they start going down this path. So it's the more you know, the earlier, the much easier it is to pick up these things, because you will, as I said, you will often find that you're not working in the language that perhaps you started off with. You might have learnt to program in Python, but it turns out you need to work in Java or JavaScript or something like that.
All right.
And if you're a very good Python programmer, it's not that hard to switch to a different programming language, as I said. There are exceptions to that. There's some very strange programming languages out there, but they're not terribly common usually. So if you've got a good foundation in one language, it's very easy to take it to another one.
All right. So thank you very much, Dr. Julian. So it was very informative. We learned a lot of stuff. I hope the students also were enlightened, both the astronomy camp student as well as the coding camp student. So that's the end of today's question and answer session. So before we finish stuff up. So there's just one more question that we have been constantly receiving. So we got two batches for our astronomy camp, the first batch and second batch. So the one question that they always keep asking is about the multiverse. And I believe the reason why they're more attached to it is because of the latest Spider-Man movie where, so many Spider-Mans, they come from different universes together. So that has, given these students some idea about the multiverse theory, but they are not very familiar with it. So what do you think about this? So what's your idea of the multiverse theory?
It's a very interesting theory. The problem with multiverse is it's very, very difficult to prove, because we can come up with the idea that there might be other universes out there, but we have at the moment no idea how to make connections between them. If they were, we don't even know how to begin to sort of contact or even prove that they exist. So we can come up with ideas in our head, but to actually get any science out of that and say, yes, we've made a connection to this multiverse over here, we don't know how to do that. We don't even know how to begin to do that at this stage. So that might be something that your students will get to, that by the time they're graduated and ready to look at different research problems, we might be a bit further along this track, and they might be able to make these connections to other multiverses. And maybe they will get all these superheroes. I don't know. That would be nice.
All right. Okay. Thank you so much for that, Dr. Julian. So I think we have finally answered the question that most of these kids had for a very long time. So that's the end of the question and answer session. So thank you for joining us once again. So we are actually very delighted. The students are delighted. So thank you very much for accepting the invitation, Dr. Julian. And
my pleasure.
Yes, and also we would really like to invite you in future as well, because we are planning of having many batches in the upcoming months. So we'll probably call you. So I really hope that you will accept the invitation at that time.
Yes, I'm quite happy to.
All right. So thank you so much, Dr. Julian. So you can also, if you don't mind, you can also share those course links that you were talking about. So it would be really helpful for me as well as the students. So that's it, Dr. Julian. And yes, and before you leave, is there anything that you want to share about today's session, about what we do here in the astronomy camp? What do you think of all of this?
I think it's very inspiring what you're doing, and I wish all your students the best. And I hope to maybe work with some of them in a few years' time. That would be really good. They will probably be better than I am, so they will probably take my job in the end.
Hopefully, one day. All right then, Dr. Julian, thank you for joining. Have a nice day. See you very soon.
Goodbye. Thank you for.
Goodbye.
Thank you so much, Dr. Julian. Bye.
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 Bye, Dr.
Bye. See you again.
See you again.
Bye, Dr. Julian.
Bye-bye.
Thank you.
All right, kids. So those who are not, those who are from the coding camp, y'all can leave the session if y'all don't mind.
So thank you, sir. Bye.
You're welcome.